Hey everyone, welcome back to the channel. Today we are doing a practical, no nonsense review of Go. This is not a beginner tutorial. Think of it more like a compact refresher for developers who's been writing Go for a while and want to revisit the fundamentals we tend to forget over time. We are going to walk through variables, data structures, composite literals, functions, methods, composition, and interfaces. They are the core building blocks of day-to-day Go development. Let's jump in. So the first topic is variables and scope in Go. Go gives you two main ways to declare variables. The first one is the short declaration, like this, and the second one is the var keyword. So let's start with the first one, and let's type something, name, Alice, age 29, height 1.72. This is the idiomatic one. You will use it most of the time inside a function. The usual printing is like fmt, printf, let's say name, person s /n, and name. I can duplicate it. Let's type age, height, rename it age. There shouldn't be $sign, and we miss comma, and the last one is the height. And if you are interested in type, you can use brackets, %t, and let's format it because it's number, point to f, and we need to type height and height. Let's run it. Go, run, and go, and you see name Alice, and the age is badly formatted because we need to use d because it's integer. And now you can see age 29, height is 1.72, and it's float 64. It's quick, clean, and automatically infers the type. Just remember, you cannot use colon equal at the package level. The second one is var declaration. You can type var max score int and fmt print ln max score. If you run it like this, you will see the number 0. You can also put it outside of the main function and type max score, let's say 100, and let's run it, and you can see 100. The next topic is composite literals and data structures. Composite literals are one of Go's most expressive features. They let you create slices, maps, and structs in a single readable expression. Let's start with slices. Let's type scores, integers, and for example 90, 85, 78, and so on. And if you print it, you can type scores, and you can see the numbers. Or you can build slides dynamically. For example, events. Integer it will be empty slice, and we will loop 10 times. And on each loop we will check if it's even, and if it is, we will append the number. And let's type fmt print ln, for example, events, and you can see 0, 2, 4, 6, 8. The another one is maps. It's key value pair, so we can use logins, map, string, and the value will be integer, and for example Alice 12, Bob 3, Eva 7. And we can type print ln as usually, and for example let's type the value of Bob login Bob, and you will see the number 3, and here it is. By the way, multi-line map literals must end with a trailing comma. That's idiomatic Go formatting. So you can see it doesn't work without the comma like this. And here it is: syntax error, unexpected new line in composite literal. So you need to type the comma to the last line. The next one are structs. It's basically object of values. If you want to describe car has year, model, brand. If you want to describe dog, it has height, weight, age, color. So let's type car struct. You need to type the name, which is car, and its struct. For example, brand string, model string, year integer. And now you can create object from the car, which is simply car and curly brackets, and brand, for example, Toyota, model Corolla, year 2020. And if you want to print it, you can simply type this line. And now you see car details, brand Toyota, model Corolla, year 2020. Or you can use shorter variant. If you remember the order, you can omit the keys, and you can just type the values like Toyota Corolla 2020, and the result is the same. The next one is functions and methods. Functions are simply func. Let's use classic add a, b, integer. I will type integer just once because I want to say a is integer and b is also integer, and the return type is integer. I will type return a plus b. If you want to call it, you type add 1, 2, and the result is 3. Methods are different. You need to use the object, which can be the car, and now you type func c because it's related to the car struct, and you want to return just string, for example return fmt s print f S and C, and you can see it's C brand, C all, because it's related to the object. And we miss the name, and for example the name can be info, like this. And also S print F. And now you can call on the object C the info method. The last topic is composition in Go. Go doesn't have inheritance. Instead, it uses composition, which is often simpler and more flexible. I will let the code like this, and I will add type engine struct horsepower integer, and I will attach function to the struct engine, and let's say engine start event print ln engine started. And the next one can be type vehicle struct engine. We embedded struct engine to the vehicle struct. Wheels integer brand string. And now if you want to create object from vehicle, we type engine, and we need to create new object of type engine. And wheels is just integer, it's 4, brand string, it's Toyota. Now a small magic, you can type v start, and this is called method promotion, and it's one of Go's signature features. Because the method start is related to the engine struct. And now final interfaces and polymorphism. In Go, interfaces define behavior, not structure. I will add type starter interface, and I want to have object with start method. So I expect if I call start engine, I will have object which is method start. For example, type boat struct. It will be empty struct, and we will add the boat and method start. For example, boat engine started. I will create car object, and I will create boat object, b boat, and now I can call start engine. Let's rename it to C, and now you can see the boat works fine because we implemented start method on the boat, but C doesn't have the start method. But if you use vehicle engine, it will work fine because engine contains the start method. So even it's not directly included on the vehicle, but engine has it, you can still use it like this. And that's polymorphism, the same function working with different concrete types based purely on behavior. So that's all, and see you the next time.